Good morning, everybody. Welcome to another day of science. This is the Tuesday walkthrough video for Tuesday, December 15th. Rapidly approaching Christmas break. All right, Tuesday folder today. Here's what we need to complete. Watch the Tuesday walkthrough video. Read the page titled Hotspot Volcanoes. We talked about volcanoes last week. We're going to look at specifically what's going on at hotspots and then complete the Hotspot Volcanoes quick check. Learning target, I can explain how volcanoes form at hotspots. Performance test, students will do a slideshow explaining hotspots. And success criteria, I will be successful when I've scored at least 4 out of 5 on the quick check. All right, before we jump into that, reminder, get your earthquake project turned in today. Had a lot of those turned in yesterday. Missing assignments as well turned in yesterday. So get earthquake projects, missing assignments turned in, all that good stuff. All right, let's jump into the Tuesday folder here. So you'll see there's the hotspot page and the hotspot volcanoes quick check. I'll real quickly go through the slideshow with you. So today and tomorrow we will look at the hotspots that are close to home. The United States has 2 active hotspots. They're just active in different ways. The hotspot that formed Hawaii has been active for millions, tens of millions of years. And is causing volcanic eruptions that have been going on for over 30 years on the island of Hawaii. There's also a hotspot under Yellowstone National Park. This hotspot's a little bit different. There's geothermal heat. There's hot springs. There's geysers out there in Wyoming. Pretty interesting stuff to see, but it's not doing like eruptions of lava and stuff like that, like the Hawaiian hotspot is. It has erupted in the past. And so we kind of have some clues about what happens when it does erupt, and we'll look at that one a little bit more tomorrow. So today we'll jump in and look at the Hawaiian hotspot and what's going on there and how it can be useful. So let's look at this slideshow here, gang. Hotspot volcanoes. Hotspot volcanoes are volcanoes that don't form at plate boundaries. Remember, we know that the vast majority of volcanoes that are around the Ring of Fire and around the world are at convergent plate boundaries. These ones are volcanoes that just form at random spots on the earth, not at plate boundaries. Hot spots are caused by a plume or a pool, a bubble of magma that just gets trapped under the crust, and then it burns a hole in the crust and it breaks through, and that causes volcanic eruptions and volcanic activity. It's kind of like what you see here. Some magma seeps up through the mantle, not at a plate boundary. And when it reaches the Earth's surface, it burns a hole through the crust, and we get some volcanoes. Here are some hot spots around the world. The ones that we'll look at, Hawaii is right out there, definitely not by plate boundary, right there in the middle of the Pacific Ocean. And then Yellowstone is right up there in Wyoming, again, not at a plate boundary. But there's other hot spots around the world that you can see as well. So hotspots are actually pretty useful because hotspots, they do not move. All right, even though the Hawaiian Islands continue to grow, the hotspot itself does not move. It's the plate that's moving. They continue erupting in the same location, often for millions of years. We also know that the plates move over time. So this creates a chain of islands, especially if it's happening in the ocean. And then we can look at that chain of islands, and scientists can figure out how or what direction the plates are moving, and moving right now, what direction they've moved in the past, and how fast they have been moving. So for example, here's a hot spot that formed Hawaii. It's active right here. This is the big island of Hawaii. It's called Hawaii. But you can see that older islands formed millions of years ago. Maui, Molokai, Oahu, Kauai. And we can see the plate is moving in this direction. So as the plate moves over the hot spot, it carries these old islands away from the hot spot. And so this is the current island that's being built where the volcanoes are active. Eventually, the plate will continue moving and move this island off the hot spot, and a new island will be made. And this has actually been going on for millions of years. So let's take a look at a couple pictures. Oh, there's a couple videos for you to watch first as well. So these are just some quick explainers about hotspot volcanoes. So you can watch those. I'm going to skip past them. Here's what I want to look at. So these are the actual Hawaiian Islands, about 7 islands. 7 main ones. There's some smaller ones out there, but there's 7 main ones. And then there are also a series of underwater mountains. And you can see, if you drew a line, it would be a pretty straight line from the Hawaiian Islands on these underwater mountains. So these are mountains that are formed the same way that the Hawaiian Islands were, but there just was not enough volcanic activity, or maybe these mountains were not over the hot spot long enough for them to actually build up and break through the surface of the water to become islands. So they're just underwater mountains. But we can clearly see that this plate, the Pacific Plate, has been moving in this same direction for a long, long time, millions of years, tens of millions of years. Very clear to see. What we can also see, if we advance one more slide, this is that same chain of islands right there, moving that same direction, continuing. Look what happened right at this point. The plate seemed to change directions. So the plate was moving almost completely just north. You know, it would pull let's say the hot spot was right here. It would erupt. It would pull the plate and pull those mountains off the hot spot, and it was moving almost completely north. But something happened at some point in the Earth's history that caused the Pacific Plate to change direction. So we can use this hot spot to get clues as far as what was happening with the direction of the plates moving as well. We can clearly see a little turn in the direction of the plate movement. So, as you can see, the active hotspot that formed Hawaii, along with the movement of the Pacific Plate over time, gives us clues as to how Earth's plates used to move. And then as we continue to find more active hotspots and sort of look at more ancient rock forms and landforms, we can continue to piece together what was going on in the Earth millions of years ago, hundreds of millions of years ago, billions of years ago. You know, we looked at, like, how did Alfred Wegener know that the plates are moving, or what sort of evidence did he have? If he would have been able to see these underwater mountains right here, that would have been a huge piece of evidence. You know, the bottom of the Pacific Ocean hadn't been mapped at that time, so again, he just didn't have that evidence. But here's another great piece of evidence that proves that the plates are moving and have moved in the past. So if it was not for these hot spots doing these things, we would not know, we would not have as clear a picture about how the plates have moved, how they're currently moving, and what speed they are moving. There's just a short little video, because Hawaii, the hot spot, the plate is still moving over the hot spot that formed Hawaii. The hot spot does not move. So eventually there'll be a new Hawaiian island. So here's a short little video for you guys to watch about will be a brand new Hawaiian island. All right, so that was a slideshow you guys will go through. You can go through it on your own as well. But when you're done with that, then go back out and complete the hotspot volcanoes quick check, and you will be all good for the day. Again, earthquake project turned in, missing assignments done. Look at the slideshow and do the quick check for the day, and you'll be all set. All right? Let me know if you have any questions. Have a wonderful Tuesday. Good luck. Bobolik out.